Now that you've reviewed scientific notation and how to put numbers in and out of scientific notation, we are going to talk a little bit about calculating in scientific notation. So yesterday, the video you watched, it talked about the fact that we use scientific notation to represent very large or very small numbers. And the reason why we want a shorter way of representing those numbers is because of all of those zeros that happen when you write those numbers. So if you're somebody in the scientific community that has to work with those numbers, then you're going to really like scientific notation because you don't want to be writing out those zeros all the time. Now, if you're somebody in the scientific community that's using these numbers and working with these numbers, you're probably not just writing them out, you're probably also calculating with them. So that's where our exponent rules come a little bit into play, and we're going to talk about how our exponent rules can help us to calculate with things in scientific notation. If at all possible, if you're somebody working with these very large or very small numbers, you're going to want to leave them in scientific notation to calculate with them so that you're not getting tangled up in all of those extra zeros that scientific notation is trying to help you avoid. The exponent rules that we've been learning so far in this unit can help us with two different calculations for scientific notation. Can help us with multiplying and dividing. Of course, there are other operations we can do like adding and subtracting, but those aren't the focus of today's lesson, since the goal of today's lesson is to connect it to some rules that we've already been using. So we're going to talk about multiplying and dividing because that's going to involve some of our exponent rules that we've been learning about in this chapter. In your notes outline for today, you have a multiplying example and a dividing example that we're going to work through together so that you can see what the steps in the process look like for multiplying and dividing. And then you have an assignment where you're going to practice both operations a little bit today. So here we go. We're going to multiply numbers in scientific notation. We have to remember that this is really just a giant multiplying with exponents problem. So to draw a connection for you, you guys have done some problems kind of like this. Like if I gave you a problem that was 2x squared times 3x to the power of 6. You guys would know how to do that because you would know to multiply the numbers and then to use an exponent rule with powers. Multiplying numbers in scientific notation works exactly the same way. We have numbers that we can multiply. So we can multiply the numbers. And then we also have powers. So we can use the product of powers on the powers, just like we would with this little problem I put up here in the corner. So working with scientific notation is actually exactly like working with some of the other problems that you worked with. So we're going to go ahead and do these two steps. So if we go through and we multiply the numbers, that means that we need to do 6.5 times 8.7. And that's going to give us an answer of 56.55. And then we still have that times 10 to the power of 12 times 10 to the power of negative 15. So our next step is going to be to go through and use the product of powers. So we just did this first step, which is how we got this answer. So now we need to go through and use our product of powers. So that's the rule, if you remember, that says if the base is the same and you're multiplying, you can add the exponents. So if I put these together, I'm going to end up with that 56.55 times what I get when I put these two guys together. So if we add the exponents, 12 plus negative 15 gives us negative 3. So now everything's all nice and combined. However, we're not done yet. There is one more step. Yesterday in the review video, they talked about the fact that scientific notation, you only want one number, one digit to the left of the decimal point. Because if you have more than that, that means that there are factors of 10 that you haven't pulled out of the number yet. And we want to pull out all of those factors of 10 from the number. So that means we need to check for correct formatting, and we need to check and see, are there any factors of 10 still hiding in there? Well, in this case, there are, because if you look at this 56.55, that number is not formatted correctly. In order to format it correctly, we're going to take just this part, and if we need to, we're going to rewrite it, just that part, in scientific notation. So in order for this to be correct scientific notation, there should only be one number to the left of the decimal point. So instead of 56.55, this number should be 5.655. So if I were to take just that circled part and put it in scientific notation, when I move the decimal point over, I'm pulling out a factor of 10. So 56.55 is the same as 5.655 times 10, or times 10 to the power of 1, because I pulled out one factor of 10. So that's just that circled number rewritten so that we can get our scientific notation formatting right. But we have to remember that that whole thing was also times 10 to the power of -3. So in order to fix the formatting, if you have something that's not formatted correctly, you have to take that number that's not formatted correctly, pull out the rest of factors of 10, and then combine them with what was already there. So I pulled out another factor of 10, but now I have to combine it with that 10 to the power of -3 that was already sitting there. So again, I can use my product of powers. If you're multiplying two numbers with the same base, add the exponents. So if I take those and I add the exponents, 1 plus -3 is going to give me an overall exponent of -2. So my final answer would be 5.655 times 10 to the power of -2. And notice that the entire time we were working, we kept things in scientific notation. So if you're working with very, very large or very, very small numbers, this gives you a way to multiply those numbers without taking them out of notation and having to mess with all of those zeros. Dividing in scientific notation works really similar to multiplying in scientific notation. So if we're going to divide in scientific notation, just like we would with another similar problem, we can go ahead and we can divide the numbers. So we can do the 1.305 divided by 1.45. And if we go ahead and do that division, that gives us an answer of 0.9. So that's our answer to that part of the problem. But we still have this other part over here, these powers, that haven't been divided yet. Since those have the same base, we can use the quotient of powers rule that we learned. And that's the rule that says to divide two things with the same base, subtract the exponents. So now we're going to go through and use our exponent rules to get this part put together. So if we do that, we end up with 0.9 times, and you have to be careful because this is a -6. So when you subtract the exponents, you're going to be doing 3 minus -6. So just be really careful with your negatives. So minus and negative we know is the same thing as adding. So 3 minus -6 is the same as 3 plus 6. So I'm going to end up with 10 to the power of 9. So now we've got the same thing going on as before. We know that if we are in correct scientific notation, that this front number should have one non-zero number, so a number between 1 and 9 in the front of the decimal point. So in this case, we've actually kind of overcompensated. So instead of 0.9, we actually need to scoot the decimal point over 1 and make it 9.0, or we know that 9.0 we just write as 9 if there's nothing after. So in the video yesterday, you learned that when we're working with a number like this, the way that we would deal with that is with a negative exponent. So since I'm moving the decimal point over 1, 0.9 is the same as 9 times 10 to the power of -1. So that is that kind of misformatted number rewritten in scientific notation. But again, we have to remember that that now has to go in with the rest of the problem that was already there. So that whole thing is also times 10 to the power of -9. So now that I'm done fixing my factors of 10 so that my decimal point's in the right spot, I need to take all of my factors of 10 and combine them together. So I can, again, use an exponent rule. So if I'm multiplying, I can add the exponent. So my final answer would be 9 times 10 to the power of -1 plus 9, which is 8. So 9 times 10 to the power of 8. Now this problem isn't super long, but it is a problem that's just long enough that it's probably good we kept it in scientific notation, because if you track through this, this would have 6 zeros in it. At one point we would have 9 zeros and 8 zeros in our final answer if we wrote out the whole thing. So that would be a lot of zeros to be trying to write out as we're trying to calculate. So that's where scientific notation is nice. So this is basically just using your exponent rules combined with being mindful about what you reviewed yesterday about correctly formatted scientific notation. Make sure that your notes look like mine before you finish your notes up. So you should have both examples fully worked out, just like they are on your screen. So if you need to go back and review any parts of this to make sure that your notes match mine, please do. And then when you're ready, you can work on the practice assignment for today's lesson.